Right, so the last time we left off, we did the we had the randomization, right? So we have the mole now popping up in different locations, and they pop up, and you can tap on them, they go away. So we're just going to continue off that, and to show for those that weren't here or haven't seen the YouTube video, where's my Discord? Here, put it here, and here we go. SRC's PY. SRC PY. What?
Trouble?
Ah, how did I get this working last time? Oh, right, okay. There we go. All right. So I think it's this wire that I have that's actually broken. Try a different wire. There we go. So what were we doing? Yes, whack-a-mole. So for those that weren't here, so this is running on my Android device. You can see it here, screen capturing. So that's what we built the last time. So what we now have is we have the ability for the moles to pop up, and then after 2 seconds, they sort of kind of go away, and you don't get any points. But if you tap on them, they go away much quicker, right? Because you just whacked them. Right? As you can see, I'm tapping on my phone. You can't see me tapping on my phone, but it's happening, I promise. So yeah. So today what I want to be able to accomplish is I want to start displaying the score onto the screen, like make a little UI and start keeping track of the score. So that means we need to do a brief introduction to Unity UIs. And Unity UIs can be very, very powerful. Okay, if you use correctly, they can give you a lot of ideas for you to be able to, like, if you have a design that you have in mind, I believe there's no reason why you can't use Unity UI system to do it. There's a lot of things that come out of the box, as they would say, that the UI system that Unity has can help you with. There might be some coding stuff you might have to do to extend, but that's the cool thing is you can extend. So if Unity's default components don't give you what you need, you can totally extend the editor. Okay, so let's try that. So if we open up the game manager here, Or if Windows Defender is on again. Okay. So the last time in here, we were just displaying, logging to the console plus 5 points because the player got 5 points because you whacked the mole, right? So let's see that in practice here. So if we hit play, you know, as the mole pops up, you whack it, and then bam, it says plus 5 points, right? And then boom, there you go again, plus 5 points, plus 5 points, plus 5 points, again and again and again. And if you wait for too long, the mole will hide, and you don't get any points. And that's very important to know that, hey, it's hiding, you're not getting any points versus, you know, you're quote-unquote whacking it or whatever, and you're getting your points, right? So the game manager has the ability now to keep track of like when the mole gets whacked, and it's up to us to do something with it. So in our case, because it's a game, we want to keep track of the score. So what do? Well, one thing for now, we can just say score, right? And then we can just go right here and just say, and then however many points we want. Now the cool thing about Unity, again, is anything that's serializable, okay, is viewable in the inspector. So if I say public int, call this score amount, right? We can say, okay, how many points are we going to get for every whack of the mole? We can say the score amount. We're going to get that many, right? You can give it a better name, you know, call it whatever you want. And then here in the inspector, because integers are primitives in C#, Unity knows how to serialize them. You can see here in the inspector, we can just grab and drag and say however many points you want to get per mole. Or we can just go here and type in 5. That's it. See, now we have full control here. So you don't have to go back into your script and then manually change again. Let's say later on you're like, oh, 5 points is too little. Let's make it 7 or 10. You don't have to, you know, go back into your code and change it. You can just go here in the inspector and just change it here, right? Because let's say you wanted to reuse this game manager. You want to have like an easy versus hard mode, and like in easy mode you give them, you know, 15 points, and then hard mode you give them 10 or something like that. There's no reason for you to have to go back and code it out. You can just change it here in the inspector, right? Cool. So now, you know, we should now be keeping track of the score now, right? So there's my plus 5 points, my plus 5 points, another 5 points. So that should be about 20 points if I did my math correctly. So now, how can we know if the game manager is a quick way to quote-unquote debug, right? How do I know how many points I have currently? Well, if you go into the inspector tab, if you right-click, you can go to debug mode, and it's going to show you everything, right? And look, it says my score is now currently at 20, right? So I can add. That's good. So it was 20. So that's great, but how do I get that number up onto the screen? Because that's kind of our goal right here, right? Is we want to have it displayed onto the screen. And that's why I think, even though right now our main focus is writing a game, a small little game here, I truly believe that Unity goes beyond games, right? I think you can use this to build a lot of different things. In fact, in the industry, as I showed you guys on the first preliminary meeting, they're even using this to make real-time animations, and then the little animation video that we saw, the little, whatever you would call a little video, it looks fantastic, right? So if you have a good design team, or if you have a good idea, if you can draft stuff up, you can use Unity to do a lot of powerful things. And if you ever use something like Java Swing or anything like that, getting something just to pop up to the screen like a GUI can take a lot of code, and then if you want to mess with things, you have to like manually change the rec, like where it's going to go, the X, the Y position. Oh, it's just a pain, right? And on top of that, I different screen sizes, and it starts to get a mess. But if we want to have a text field, just to display something, this is how easy it is with Unity. You go to UI. Oh, I'm grayed out here. Go to Create, UI, and we want a text. So we just hit text, and then there it is. It's right there. Beautiful. Right? I don't have to go in and say rect and then X, Y, and I don't do any of that. Right? So let me switch out of debug mode. And now, to work with UIs, you should work in the scene view. Switch this to 2D. Right? Select the text or the canvas. Go move your mouse into the scene and then press F. So that's your canvas right there. Okay? If we zoom in using a scroll wheel right here, this is our drawable area. Here's our little text field. As you can see, it's out of the field of our canvas here. Now you'll notice that as I stretch this out, you can see the text field comes into view. Now why is that? So the entire Unity drawable area for UI stuff, everything has to be inside of this canvas component. This helps you draw stuff. Unity draws things on a hierarchy based. Okay, so the higher up you are in this hierarchy, okay, the lower you actually are in the drawable sorting order. So, for example, we have this canvas. I can go ahead and put an image. There's my image. And then I can put my text. Let me put my text right in the middle, just like my image. Now, as you can see right here, my text is behind the image. Why? Because Unity does the drawing order based off where you are on the hierarchy. So the higher you are, the more to the back you are. The lower you are in the hierarchy, the more to the front you are. So if I wanted to bring my text to the front, to be in front of this image, I can just move my image to the back on this hierarchy, and boom, now I'm drawing the text on the front. Okay? Now, let's say I wanted this text and this image to be kind of together, but you wanted the image here to be as your background. So the convention is to just parent them. So you can get the text, you can parent it here, and now when I move the image, they move together. Why? Because the text field is now a child, right, of this image field. Now we're all moving together like this. But say you wanted to have, your score, like let's say right here or something like that, right here. Okay. We still have this issue where as I move this, it's possible that the text field goes out of bounds, right? Or if it's too big, it's too close to the center, and it's blocking our view of the game. So what do? We need to tell the canvas, hey, you need to resize yourself based off the screen size. And we can do that easily by going to the canvas right here. And you see where it says UI scale mode? Switch this over to scale with screen size. And now, no matter if I move this, however small it becomes or how large, notice how wherever I place these components, they will always be in that location and they scale. So they become smaller or larger depending on the scale of the screen. So everything is uniformly scaled. Does that make sense? We can even anchor things. For example, if I have this image and I want to make sure that this thing is always on the top left-hand corner, we can use these anchors, right? So if we click on this, if I click on this, you'll notice that they call them flower petals. These are your anchor points, right? Now my anchor point on this particular element here, this image, is on the top left-hand corner. So if I were to rotate this on the z-axis, oops. Yeah, okay, so it doesn't do it, okay. So if I were to, probably a bad example because it's not parented to anything, but let's say this text image. So let me put this back to the center, and let's take this text image and move this to the top left-hand corner. So if I take this image and if I make it bigger, or if I move it around, obviously it's always going to stay in the top left-hand corner, right? But notice how if I move this about, it always wants to stay on that corner. It's always going to be referencing that corner, okay? But we want this to be right in the corner, right? So if you click on this, if you hold shift, this will also move the pivot, right? So now we have the pivot. So now if we rotate about the z-axis, we're actually rotating about our little pivot there. Our pivot's now on this top left-hand corner. And if we hold shift option, if we hit this corner now, it'll snap right into the corner, very snug, right? Then we can change the height here manually like that. Now, suppose I have my image to be this size, right? Obviously, this is very big. So this is an obtuse example, but let's just say. Here on the game view, I have this 16 by 9 scale. But what if the user is using something else, like a 5 by 4? So you can't control what the user is going to use, right? So you need to make sure that your UI fits. So let's say I click on this 5 by 4, right? So as you can see, it's taking up a different amount of the screen because we're using fixed pixels, right? We're saying, hey, it's going to take 324.4 pixels, whatever 0.4 pixels means, right? If we do 4 by 3, there you go, 16 by 10. So you can see it's always taking a disproportionate amount, right? To see this clearly, let's go to standalone, and let's free aspect. I'm sorry. Let's move. Oh, you see here, it's in the corner, but look now it's taking a disproportionate amount of screen space. Sometimes it's small, sometimes it's larger. What if you wanted to have a specific corner, right, of the screen to always be this size, to always have this image there, right? How would you go about doing that? Well, that's where these flower petals come into play. So I don't like playing around with the petals directly, right? Because I'm very like OCD. I like my numbers to be, as close to whole as possible. So if I have 25 and I cut it in half, it should be 12, 0.125. A lot of people will just grab and then they'll be like, that looks pretty good. And then like this right here kind of like angers me. I don't know why, but it kind of just I need to see like something that makes sense. That doesn't make sense to me. So what I like to do is if you go under this anchors part right here, you see this max 0.5375. I don't know what that means, right? So I like to make things in increments of either 0.1 or divisible by 2, something like that. I don't know, something that makes sense. But anyways, our example here is I want to take the top left hand corner, for example. I want to always have that quarter of the screen always. Why? I don't know, but I just want to do that. So this max, if we click on this X, you can see how we're moving the petal around, right? And so it snaps there at 1. So 1 must mean that on this max, the maximum part that this image will take is wherever this is at. And these is actually a normalized value. So you can think of this as a percent. So this is the max that the X will take is 100% of the width of whatever the screen is, right? And you can see where it says this right. This is padding. So there's 475.6, units, we'll call them, of padding towards the right. So if I were to just zero this out, it takes up the entire thing because there's no more padding. If I increase this, it's like me increasing padding. You see? So if I wanted to just take a quarter of the screen, what does that mean? I want to take half. The maximum amount I want this image to take is half of the X right? And I want half of the y. The thing is, for the y, see this right here, this pedal right here. Notice right here how it's changing the bottom pedal. This right here. So this means that this pedal controls the minimum. See that? So if I want the top half of this screen, I need to start at half, like that. See that? And so now if I just zero everything out, so basically saying no padding, I will always have this top left-hand quarter of the screen, regardless of the size. So now in free aspect ratio, if I start making this all disproportionate, you can see no matter the dimensions of the screen, I always have this top quarter. Does that make sense? So if you wanted the top header, for example, you want to just use the header. You know, one way I like to do this is I'll click on the image. I'll click on this, the anchor. I'll use Shift Option, and I'll click on the top like that, and I'll give it a height. Say 40 pixels. I only want, or 50 pixels. I want only the top 50 pixels. Okay. So this could be like a header. Okay. But what if you want this to be a little bit more dynamic? Because 50 pixels might be too small. Because you know those new phones, they're really long now, right? That can be a problem because it's too long and 50 pixels could be too small. Maybe your header where it says, you know, welcome to whatever, it's going to be too tiny. So how do we make this so it's scalable? Well, if you guys have ever done web development, right, when you're doing your CSS, you don't really use fixed pixel counts. Sometimes you do. What you generally use is percentages. Oh, I want this to take a certain percentage of the screen, right? That's kind of the idea here, right? So right now I'm in WebGL mode. So if I switch over to Android, switch platform, that's going to take, you know, however long. Okay. Cool. Sweet. Now that we're in Android mode, what's really cool is that here now we have all the popular, right, the most used Android device screen resolutions. Now I can begin testing to see how my UI is going to look on my actual phone. So we have portrait. See how tiny that looks? See, I think that looks too tiny. And if we have something that's higher resolution like this one, it's going to look even tinier. So what if I want just to have, like for example, the header, I want it to always be a specific amount. Like let's say 10%. The top 10% of the screen will always be my header. My, like, you know, welcome to whatever game or whatever. So how would we do that? Well, again, we're using this percentages things, right? So if we click on this image, so for the minimum, what's 10% of the top? That means that the minimum amount is 0.9. And the max on the y is 1, and the difference is 10, or 0.1, or 10%. So notice the little flower petal. Notice where it's at now. So if I zero this out, remember, having these things are kind of like margins. I will always now, my header is now always 10% of the screen, regardless of screen size. So if I go here to something that's a little bit smaller, like this portrait right here, this one's a little bit smaller. If I go here, that's a little bit, you know, the pixel density is different. But notice I always have 10% of the screen as this little white header. This is very dense. But look, I still have the same amount, regardless. Right? We can set to maximum so we can see how it's going to look here. Yeah. And to see a real world example, like something that I'm currently working on, so I'll just show you a quick example of something that I'm working on. Okay. Okay. I'm basically using the same idea. So notice so right now I'm currently like testing some UI stuff. And so obviously you can see where I put things. So that's called my header and that's called my footer. my header is taking up 10% of the screen on the top, and my footer is taking the bottom 10%. And then I have my body. Now my body is taking a minimum from the bottom 10%, so it's offset from the bottom 10%, and it goes all the way up to 0.9. So I have what is that? 80% is my body. That's all that I'm going to use for my body. Now the reason why I want to do that, the reason why I want to separate these things out is because I want to have things on my footer and my header that draw on top of the body. Right? So in the off chance, for example, if I had like an animation in my body, when it goes over to the footer will draw on top of the body. Right? Now sometimes you don't want that to happen. For example, here's a good example. I have this drop down menu to switch between light and dark mode on my UI. So if I click on this, it will still draw on top of the footer, and that's a good thing. Or else you wouldn't be able to see your options. You wouldn't be able to see that there's a dark mode. And it just transitions between these two, right? So there's a good example of how you can use, these percentages for your UIs. And in fact, if you go to any website, there's always a portion of the web page that's dedicated to like the header and the footer, right? So let's go on the interwebs and let's test this out. So a very popular website is like YouTube. And when you look at the page, notice something about the UI. What do you see? Right? So you have a header. In fact, when I scroll, the header comes with me. So there's this element here, this search bar, this navigation bar is what they call it, is always taking a certain amount of this screen. Right? Now they'll have some logic so it doesn't get too big. So if I were to like make this a little bit tinier, and then if I start scaling it myself, let's see. Regardless of the screen size, it's always taking up a certain amount of the screen, regardless. That way it stays proportionate. So let me do a little bit more scaling. See? Regardless of how small I make this or how large, this navigation bar will always take up a certain amount of space, but it's always going to be scaled in such a way that everything is proportionate. Now the inside, you saw that the UI, realigned itself. That's a little bit different. That's like a flexible layout. But regardless, we always have this toolbar, this navigation bar, right? Let's look at this guy right here. Now let's start scaling this up. Right? Isn't it since it was small to me scaling it up, isn't it always taking a certain amount? It's always going to take a certain amount. There you go. It's always going to take a certain amount. So my thing is, when you're working with UIs, the best way to look at how people lay things out is honestly look at web pages. Especially some of these newer, fancier web pages, they look really cool. Especially the way they lay things out. That's a good way for you to get some inspiration. In fact, I like Drupal. I think it's Drupal with 3 P's. Not Drupal. What is it? Dribble. It's like 3 B's or something like that. So these guys are like UI UX designers or whatever. They throw some stuff up here, it's, to get some contract work or whatever, but also to just show you designs of like how they're working on their UIs. And it's really nice to see how they, do their proportions of, how they lay out things on the screen. And some of these are actually interactive, like some of them are animated. So if you just hover over, some of these will have a way for you to, does that one? Yeah, so, some of them are animated, so you can actually see what's going on. So this is supposed to be some kind of tablet, I guess. And look, note, what do you see here? Again, they have this header, and it's always taking this certain amount of screen space, right? So it's very important when you're making a game that you don't just, let me just throw some text up here. No, you should start thinking about UX design early on. On Discord, I'll link a bunch of links to some UI UX talks from Google and other people that have done a lot of research on this. And it's very important because there's a difference between having a game and then have just the design look very, very crappy, and then just redesigning it just becomes a whole new thing because now it looks so nice. It's very intuitive to work with, and people will really appreciate that. And in fact, that'll probably be the determining factor of whether or not people want to stick around and play your game. If the menus make no sense, if where the scores are at just looks all ugly, if it's in the way of the main game, that can just be very bad, right? So that's just a UX problem. So start thinking about this early on. That'd be my recommendation, right? Okay. Cool. So how should we have our layout for our score? Well, let's look at some simple mobile games. So we'll just go to, I don't know, Android, mobile games, And it's a nice way to see how, people lay out their UIs. So here's an example of like a shooter game, for example. So here at the top, they seem to have this compass, right? They have some settings here. Do they have a score? They have a score, and it's in the top left-hand corner. Why? So it's not so intrusive. If you had the score right here in the middle of the player, isn't that kind of intrusive? Right? Because they can't see. They're like, yeah, I care about my score, but I need to know who I'm shooting at or what my target is. So let's look at another example. Here's a racing game, right? Again, here you want the user to be looking here, right? And these are some stats that you probably need to know. How fast are you going? What gear you're on? What lap? But notice how it's not intrusive to what you want the user to be looking at. So when you're designing your UI, make sure that whatever you want the user to be looking at, none of the UI is it's not intrusive. You don't want to do that. In fact, a lot of newer games, their UIs are so basic. Like, let's take an example of a game like, let's say, Bad Company. Let's look at their UI. See if there's an example of their UI somewhere. I just want to know like their company one menu or something. Here we go. So here's an example, right? This is Bad Company 2, right? Yeah. So you can see, their UI can get kind of a little bit crazy, a bit much. But I don't know if anybody's noticed, but for example, in the new Battlefield, I think, what was it, Battlefield 1, I guess? Menu. Their menu is very sleek. Look at this. This is a stark contrast between the two. Right? Look how minimal this is. You can see a lot of the background. There's none of all this like, let's make this background just white and some black here. No. Look, it's see-through. They're using Gaussian blur to blur out the background so it looks all pretty. This is very modern. You're still getting the same information. It's just laid out differently. So again, UI matters. Okay? This is not a UI talk, but I'm saying, like, you guys want to work on games. If you want to show your employer, hey, here's the little thing I was working on, the first thing they're going to see before they even play your game is going to be the UI. And it needs to be intuitive. If you have to explain, oh no, don't hit that button, you need to hit this button first, that doesn't make any sense. It needs to be intuitive. And notice here for like a lot of these options, it's just a really big button. Could you do this on mobile? Maybe, but it makes sense here. Why? Because it's desktop. So my recommendation is if you want to work on games, there's a lot of free games out there. Download a lot of these free games, especially the ones done by like EA or Zynga, all these companies. Why? Because these people have invested millions, if not hundreds of millions, into research, right? And their UIs are being done like almost in a scientific manner. Like what kind of colors they pick, What kind of buttons are they using? Are they rounded? Like, are they square? Is there a drop shadow? What kind of color palettes are they using? Stuff like that. So download them, look at them, see how they play, look at the animations. How do they make you feel? One of my favorite, probably like game, I guess not studios, but get publishers is Nintendo. I love their UIs. It makes sense to what Nintendo is. In fact, if you play like, I think it's like Mario, the one on iOS, the Mario Run or something like that, the UI is just, I love it. You click the button, it's like blah, 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 it like wobbles and stuff. It's so cute. In fact, that game's made in Unity. So, that's an example there. Pokemon Go, made in Unity. You guys didn't know that. So the things you can accomplish in Unity is like, you're just limited to your imagination right here, right? So yeah, think of like placements, right? So let's keep looking here. Here's, I don't know what this is. So notice where the UI is at. The UI is all around the corners, but not intrusive to the middle. So you can see there's this whole, don't let the UIs get in the way of the main game, okay? This is cute, right? So that's pretty nice. This looks very much like Zelda, but I'll give it a go because it looks nice. See? So you have your hearts over here, you have your little mini map, your controllers here, your control here, and these are like your buttons, right? And yeah, and so none of the UI stuff is intrusive in the middle. Okay? So get this guy, same thing, I guess. So cool. So does it make sense what I'm trying to come across here, right? So make sure when you're designing your UIs that you don't be too intrusive. Be as minimal as you can. In fact, I would highly recommend you look at what DICE has done on their games. Say what you will about their games, whether you like them or not, but their UI is fantastic. I absolutely love the sound design, and I love their UI design. So I would highly recommend you just look at any of DICE's games and just look at them and just be in awe. Okay. Cool. So here's ours. Not as pretty, but not yet, right? So I'm gonna call this I'm gonna change this to HUD because it's my HUD, my heads-up display. That's what HUD stands for. And now I'm going to change this. I'm just gonna name it header, not header, right? And now let's start putting things where they need to be. First, where should the score go? Should it be on the left? Should it be on the right? Left? All right, let's pick the left. So we can click on our text here. We can call this score. So since we want this to be on the left, always, we're going to hold Shift, hold Option, and we're going to click this left thing right here. Bam. It's going to put it there. And then what we can do is this text, you see how it's on the top left-hand corner? Looks like it? That's not because of where we placed it at. As you know, if you worked on any kind of web doc, you can put the text in the middle, the top, or the bottom. So that's what this is. This is paragraph alignment. Notice right here, it's on the top. So we can put this into the middle. We can put this to the bottom. We obviously want it in the middle. So that makes sense. Now, if you look at it here, the text it's a bit too close, right? It's a bit too close. We want to add some padding or some margin. So what can we do? Well, here, remember, we can just position this a little bit, and give it some padding. In fact, I like to give paddings of about 25, 10, 15, 20, 25. 25 looks pretty good here, right? So now we have some padding there, okay? Now, we're not going to have this background be white, but we're going to just use this as a reference as to our drawable area here. Oh, the screen fell asleep. All right, here we go. Okay, so as an example, eventually we might have something like score 10. That's eventually what our UI is going to look like, right? So we'll just leave that as ... for now. So that's already kind of looking like a game. No? Sort of, kind of? Pretty good, right? Just, we just moved it there and not bad, right? Don't mind the font. Okay, yeah, the font's ugly. This is using Arial. We might want something a little bit more fun, but we'll get to that in a second. Okay. Now, let's look at the text font size. If we go to portrait here, dang, that's pretty small, right? Let's go to landscape here. Okay, so for landscape, it looks like we're doing pretty good. Now, the good thing is this game is only going to work on landscape. But if you ever wanted your text to also be big enough for you to be able to read, regardless of screen size, you can use this thing called best fit, and it'll grow in size based off the size, not only of the screen, but specifically the component, the size of the component. So this text right here, if we click on this, it's going to try and take up as much on the vertical as possible and on the horizontals. That's why it's going to scale. So there's this min size and max size. So you can turn this down a little bit. Before it was at 14. So we can say, 20, 25 looks pretty good, decent. It's legible, right? Remember, in the Unity editor, it looks like this, right? But this is going to be on a mobile device. So even if it looks kind of big like this score, if you use 14 font and you put it on your device, it might look too tiny, right? So something to think about. All right, cool. So enough about that. Now, how do we get this text to, the score to actually spit out the text? So let's do this again naively. A lot of what we're doing right now is naive. We're going to go back and we're going to fix this stuff. But for now, let's do something very, very bad. Please don't ever do this. But let's do some really harsh dependencies here. So in my game manager, once this thing is done reloading. Okay, here we go. We're going to say, remember, that's a text component, right? That falls under the namespace of unityengine.ui, because that's part of the UI. So Unity likes to separate all their modules into their own namespaces. So that's a good thing. So we're going to say, using unityengine.ui, I can now say public text, and that's the text component that we want. We can call this score display, for example. Okay, cool. Now, after we increment our score, we can say this dot score display dot text. So here we can put whatever text we want. It just takes in a string. Is equal to score, right? And this is just concatenation, and then the current score, right? That's it. Now we have a way to update the text. Again, this is not a good way of doing it, but I'm just showing you. Right? So here we go. And it's going to serialize it. There you go. So we're going to, again, Unity, the beautiful thing about it is just dragging the reference just like that. Very nice. Now we hit play here. So wait for the mole to pop up. There you go. Boom, 5 points. Boom, 10, 15, 20. There you go. Yeah, it just keeps going on forever. Right? And if I don't hit it, I don't lose any points, and I don't gain any points. Just nothing happens. All right. But you'll notice that when we first start the game, though, when I hit play, I haven't gained any points, but it still says dash dash, right? That was just like a placeholder text that we put in there. So obviously, you don't want your text to say dash dash. You want it to say 0, like you have no points. So one thing you can do is you go into the UI and just change it to 0. Now, you could do that, but you shouldn't. And let me tell you why. From my experience, by having it be 0, I've had issues where I was just like, okay, for some reason, sometimes the score updates and sometimes it doesn't. What the heck is happening? And if it just says 0, you have absolutely no idea when this actual text component is actually being updated. So you're kind of in the dark here. But by just having it dash dash, all you know is, okay, this thing has not been refreshed yet. Why? Now you can start digging. Maybe it's because the text, the HUD, usually have a separate script called HUD, has not been properly hooked into. So it has no idea that there are changes going on yet, right? But if it has 0, you're going to think, everything's hooked up, right? Because it says 0. That's kind of what you're expecting. You don't expect to see dash dash. In fact, if you have really poor internet connection, and when you first log into a game, for example, a lot of the UIs will have dash dash or NAs, meaning not available or not applicable. It'll have a lot of that stuff. Why? Because they haven't been refreshed yet. So if you have a really bad connection and it's waiting for it to get hooked, there'll be a moment, sometimes you'll see in certain games, where a lot of the text has not been filled in yet. And then as soon as it has an ability to finally tick and update, you'll see all those things just automatically populate. That's good for the developer, so they can see, hey, certain things haven't been hooked into yet. So it doesn't seem like much, but when it comes to debugging process, I find that this to be very helpful. Okay. Again, just my 2 cents. So how do we get this to be done properly or whatever? So we should make our own HUD script, because the game manager should not have access to this. Okay, why? Because I should be able to delete this UI and the game manager should continue working just fine. For example, in our case, that won't happen. I'm going to delete this. My game should still be able to run. Why? Because Whack-A-Mole should not care about the UI. But because of the way I've coded it, there's a strong dependency. So let me hit play. Okay. So everything looks fine. Error. Get this error. In fact, you should always have this error pause. So when it happens, it just stops you right in your tracks. So we're waiting, and then pop. Oh. So my game flow has now been, stopped because there seems to be an error. And what is the error? Well, there's a null reference. Why? Because I deleted the UI. So why should my game manager, my game logic here, why should that be tied to my UI? They should be completely separate systems, right? But the way I did it, you saw it worked. Works great. Very naive. In fact, if you go on YouTube and you watch a lot of the tutorials on Unity or whatever, or how to make a game, they do this a lot. And it's good if you're first starting out. But they're not teaching you software engineering or development or anything like that. They're not doing that properly. So their concepts about separation of concerns doesn't come into play. They're just trying to get something to work. And in a game jam or in a hackathon, works just fine, but is not production ready in no sense of the word, right? Because look at here, we just destroyed the UI, and boom, we have this issue here. So what do? We need to separate them. Now, how do we separate these two systems? Well, for one, let's bring back our UI, because I don't want to do that again. Cool. So inside of our scripts folder here, we're just going to create a new folder. Call this UI. Okay. And then we'll call this, HUD. And we'll create a script called HUD. Just like that. Let's open this up. Reload. Here we go. Okay. Now the HUD means heads-up display, right? And for the purposes of our game, we only have one type of HUD, right? So if you guys ever played Halo, when I say, hey, we're hooking up to your HUD or whatever, you have all these, you have the shield bar, you have your ammo count, blah, blah, blah. That's your HUD, it's your heads-up display, right? So it makes sense that our HUD should have a reference to our score component, the text, right? That makes sense. It's a heads-up display. That's kind of its job, right? So having, access to that, it makes sense. This system should. There should be a strong dependency, in fact. In our case, we're calling this score. Okay. So let's go back to Unity, and let's hook up the text with our HUD. So let's clear these errors. Okay. To add the component, again, you can either go to add component, type in the script name, for example, HUD, or you can just drag and drop just like that. Or you can grab this and drag it on top of into the hierarchy. Same thing. So there's 3 different ways. Actually, there's a 4th way. I believe you select this, you can go to component, you can go to add, and it'll do this for you. That's a long way though. That's pretty fast. Okay, and look, it says, hey, I'm looking for a text component. Can you find me one? So if you have a bunch of these, or if you don't have that many, or you don't want to drag it for whatever reason, there's this little circle thing. It's barely noticeable. If you click on that, it'll actually try and look for everything inside the hierarchy in the scene view. So there's a score component. We can click on that. If I click on this, it's going to show you which one it means. That's pretty cool, right? And it's this one. If you didn't want to do that, you could just have dragged it like that. So there's a lot of options here, okay? Now we need to go to our game manager, and we need to remove this. That's obviously going to break this, and that's okay. There we go. Cool. Now if we play the game, we no longer have a scores updating, so we kind of tread backwards, right? But moving forward, we're going to have a better system in place now. So how do we do this? One way is to just do something through events, right? So let's go to the game manager. And so we can do an event, right? So we can say, OK, public event system.action on scored, right? Now, we need to know the amount of points, right? Since we're using an integer, we need to pass an integer. OK? So to know more about system.action, I highly recommend MSDN. And get used to learning documentation, right? Because you guys are all software engineers, so read this. I could go over what this is, but I'd rather not. I want you guys to actually maybe do some kind of homework. The reading is very small, and there's some examples here, right? Beyond of what I'm talking about, right? But works all the same, right? Cool. So we've already kind of dealt with these events before. Remember, we had our mole. We had 2 events here on our mole, on got whacked and on hidden. So it's not the first time we've seen this. But now we're making an event on the game manager. So we want to say, OK, again, if on scored does not equal null. Now, why are we checking to see if it's null? Well, because it's an event. When you're subscribed, it's not null. If nobody's listening, the object is null. OK? Again, the object that we're going to pass, and it's going to be the score, right? On score, this.score, how many points they currently have. Okay. Now that's a lot of code. And again, last time I showed, instead of doing it this way, right, which is totally valid. So I'm just going to comment this out right here. A lot of times, sometimes you'll see in people's code that you'll find on GitHub or whatever, they'll use something like this. This.onScored. C# has this question mark that allows you to null check in line. It's syntax sugar. This will eventually become an if statement. But just so you don't have to write that much code, The question mark basically says, if it's not null, do the following. And I want to basically invoke this method. And I want to pass just like that. Not bad. So who has to subscribe to this event? And how do we do it? Well, the person that needs to subscribe is the HUD. The HUD needs to know, hey, let me know when the score gets updated so I can display it, right? That makes sense. But how do we get these guys listening to each other without having a strong dependency? So how do we do that? Well, the game manager doesn't need to know that the HUD exists, but the HUD may need to know that the game manager exists, right? So there's not this bilateral dependency. It only goes one way. Why does that matter? Well, let's say we want to do some modifications to the game manager. In fact, we made a game manager that's so good, we want to rip it out of this game and put it in a different game, right? It should work regardless, if that's the case. If we have the strong dependency that if we move the game manager, guess what other code we need to move with it? We need to move the HUD along with it. But what if the game has a different HUD system? Well, we're stuck, right? But if everything is driven through events, well, now we have independency, right? So how do we do this? In the first meeting, or the second meeting, I talked about the singleton pattern, okay? In fact, I think we wrote one. I think. Let me see if it's still here. It is. Because now we can actually use it. And that's it. Now, by using a singleton pattern, what this means is that there should never be more than one game manager in an app at a time. We can destroy it and later on create it. We could do that. Remember, this is an anti-pattern. So you don't have to follow the rules of this pattern, because it literally is an anti-pattern. Okay? So we can destroy it and re-enable it whenever we want. But we never want more than one instance of game manager to ever exist in the game at a time. So what can we do now? Well, in our HUD, remember these methods here, the start and awake, this is all Unity, magic methods, you can call them. So this start method, again, this is going to execute when Unity loads up this script. And I'm not sure if I showed you guys the last time, but script execution order Unity. To learn more about these quote-unquote magic methods, oh, no, not here. Order of execution of event functions. There we go, right here, the manual. That's what we want. To learn more, go here. Okay? So these are all the quote-unquote special methods that Unity will fire. Okay? There's quite a bit, right? And you've already seen some of this. We've already interacted with a couple of these. We've already interacted with awake. I think we did start. And update, which is right here. This is all the physics stuff. So you want to work with physics, you need to work at it in this frame, or in this call, we'll say. Because the physics and the rendering system are independent of each other. In fact, the physics system, the physics engine, ticks at a fixed rate at about 50 times per second, versus your rendering loop may happen a lot more than that. It could be 30 frames per second, which would be less. It could be 60, it could be 120, whatever, right? So we need to subscribe. So what do? Say game manager dot, what did I call it, instance? Yeah, I called it instance. Again, this is just part of the singleton pattern. Game manager dot instance dot on scored. Hey, check it out. Right? We have this event now that we can subscribe to. Now, bless you. Now, how do you subscribe to events? Well, remember, with actions, you use the plus equals to add. To not listen, you use minus equals. Plus equals space. Now, here, what's it called? Visual Studios is going to try and help you, make a method method stub, if you hit tab, it'll generate one for you, right? Now, when it's highlighted like this, it gives you the chance to actually change the method. So you can say on score changed, right? That's kind of typical. The on is usually indicated that, hey, this method is going to get executed via an event. So every time you see a method that says on this, on that, just know that that particular method will get called based on some kind of event. So if you've ever done a lot of coding, maybe on some of like the web pages, there'll be like a on loaded, on refreshed, on this, on that. That's what that means. It's kind of a convention. We can change this to be score. Okay. Now we're just going to say this dot score dot text equals score score. There we go. So let's go back to Unity. So our game manager no longer has that dependency on the HUD, right? Our dependency is now one way, right? The HUD needs to know that the game manager exists. That's okay. You can't run away from dependencies. Eventually, there's going to be a point where two modules will need to talk to each other eventually. But you need to have them separate just enough so that these things can be reusable. So our game manager is reusable. Our HUD may or may not, might need some refactoring. So let's test it out. Hit play. Again, it still has the dash dash. We'll fix that. But hey, look, we're back to it, right? We're still getting our points. But we no longer have the dependency, right? So if we were to just get crazy here and just literally just delete this, right click, delete. If I run this now, just like that, there's no dependency, so there's no errors. Check that out. See? In fact, let's do something crazy. So here's the HUD. I'm going to disable this. So it's almost as if I had deleted it. Remember, it hasn't been loaded yet because the start method has not been called on it. So they're not linked. Okay? So here you go. Here we go. Here we go. Now let's inspect our score here. It still says score dash dash. Right? Still says that. Let's enable it. So there it is. It still says dash dash, but check it out. Now it says 20. Why? Because the score was 15, now it is 20. And that because the HUD had not yet been initialized. It hasn't had a time to hook into the game manager. Now it is. So the next time it clicked on it, the game manager let it know, hey, by the way, we have this many points. Right? Now, how do we fix the dash dash? As soon as we subscribe, we want to get the score as well. Right? This gives us a way we initialize, and we automatically begin setting up the score. So how can we do this? Well, because the game manager is now a singleton. Where should we put this? I'll put it right here. We can now create a property. Public int score capital S. Again, this is C# code, right? So these are properties. Think of this as a getter and a setter. We want to get the score. So we're going to say get return this dot score. Yeah? It's good. That's it, right? Now let's go to the HUD. After we initialize ourselves, after we subscribe to the game manager, this is our initialization stage. We need to initialize our text to represent what the current score is. So we're going to say this dot onScore changed game manager dot instance dot score. Oop. There it is. Yeah? So now let's go back. Our HUD, remember, is disabled. We didn't delete it, it's just disabled. Now let's hit play. Let's play a couple rounds. See how many moles we can whack. 1 right there. So that's 5 points. That's 10. That's 15. Yeah? Again, our score has not been initialized yet. It still says dash dash, but check it out. Boom. We enabled it and it says 15. Yeah? In fact, we can disable it again. Boom. 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 What happens when we enable it? It says 30. But how many points do we really have? Ah, there we go. Right? So let me disable this guy. Boom. 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 55. Now that worked. But what's the problem? Because there's a problem now. Every time you subscribe to an event, you need to unsubscribe as well. So let's see. Let's just see what can happen if we don't do that. Let's just see what happens. Okay. So we enable. We're subscribed. We say we have 0 points. Click, click, click. We have 15 points. Now, what happens if for some reason we delete this? Okay. It's still running because remember, when the moles hide, you don't gain any points, you don't lose any points. So we haven't done anything yet. Now let's try and, oh, look at that, errors. What happened? What happened, right? Let's look. Missing reference exception. Now, the text is kind of hard to read, and I'm not on my Mac, so I don't know how to blow this up, but it says the object of type text has been destroyed, but you are still trying to access it. What does that mean? Well, remember, we subscribed to an event, and what happened? We updated the text. The thing is that text no longer exists, right? Because what happened? We destroyed it. It's no longer in the scene. It's no longer in memory. It's gone. But we're still trying to reference it. So what happened? Null reference. So if you look at the bottom here, it gives you the stack trace. So let's start investigating. So update tick got called on the event system. That's how we're able to get the touch events. Now let's go up, up. So we're going up, 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 up. And a lot of this stuff is Unity-based stuff. So let's look for our script, right? Any of our code. Maybe there's a bug there. So we're going here, and mole at 20. So let's go to mole. So that's our first. Remember, we have to do detective work here, right? We know the answer, but let's go through the detective work. Line 20, got whacked. Okay, got whacked. So on got whacked, who was listening? It looks like game manager was listening. Let's go to line 38 of game manager. There's line 38, right? Because this guy was subscribed to got whacked. See? And then we have this error. We have this thing here on scored. Right here, 38. Let's go to line 38. That was the next thing. So we have this score that got called. Remember, this was an event, right? And then we go. Line 16. We went to HUD. Line 16 here. What happened? This no longer exists. In fact, this entire thing doesn't exist. But what do we have? We have residual, calling code. Right? The event has residual code there. It's like a dangling pointer almost. So we deleted the actual the actual HUD, but we didn't unsubscribe. So what ended up happening was when the event got called, it got called on a ghost method basically, and it tried to access a reference to this text component called score, and it didn't exist, so it calls the null reference, which we're all kind of familiar with those, right? So how do we fix this? My recommendation, whenever you're doing something with an event, is the following. Instead of subscribing and start, okay, When in doubt, use on enable. Okay. So this on enable will get called by Unity. If you look, remember, if you look here, look at this. It's part of the initialization. There's awake, and then there's on enable. In fact, on enable will get called multiple times. I think I went over this demo where you're able to enable and disable a script using the check mark. When you enable it, the check mark turns on. It calls that method. When you disable it, it's going to call the on disable method. So there's two different methods that get called. So on enable, that's when we want to actually subscribe. Yeah? And then we can go ahead and say on score changed. Like that. When it gets disabled, we want to unsubscribe. Because if we look at the execution order here, decommissioning, meaning the game object or the mono behavior is getting removed from memory, right? Or something's happening. If onDestroy gets called, it means, hey, this game object is just about to get destroyed. I'm just letting you know. OnDisabled means this component has just been disabled. Okay, and you can do some stuff. In our case, if it gets disabled, we want to unsubscribe, right? That way we don't have, there's no more residual code. So let's go back here. Okay. Now we have our HUD here. It's disabled still, so let's get some points. Boom, boom, boom. And then enable the HUD. It says 15. Same thing, right? And let's whack a couple more moles. There's our 20, 25. Now, check this out. Look at the score here. I'm going to disable the HUD again. Look over here, this 25. It's no longer going to update. It stays at 25. Why? Because it's no longer listening. If we re-enable it, it catches up because of the on enable. If we destroy it, no errors. Why? Because we unsubscribed. That make sense? Any questions on that? So every time, and no matter what language, no matter what framework, no matter what library, if there's ever a, by the way, you can subscribe to this event, you should already know, okay, I can subscribe. Now I need to figure out where in my code am I going to unsubscribe. Because you can't have dangling pointers, okay? Or residual code. This is like ghost method. It doesn't exist. Somehow it still got called and bam, we got that error. That's because it uses kind of like reflection, sort of, kind of. So even if your reference is dead, it's still going to try and call it, right? Because it's kind of like, it's doing some magic. We'll call it magic. Exactly. And it still exists. It's just going through and just calling them. So when you subscribe to the event, it wraps that method around a custom object. Even though your object is technically dead in the middle, their object still exists wrapping basically nothing. And then when it gets its turn to get called, it calls it, but it's like there's nothing there, null reference. And that's basically what happens. Does that all make sense? And that is part of also the event subscriber pattern, right? The subscriber notifier. I don't know, different names for it, but yeah. Think of it like YouTube. You subscribe, something happens, you get notified. But what happens if you delete your account and then the person uploads a video and then you still get a notification on your email? That's weird, right? You subscribe to PewDiePie and then you deleted your account, and then PewDiePie uploads a video, and then you get an email saying, hey, PewDiePie uploaded a video. It's like, what? But I deleted my account. There was no unsubscribe. And then you're stuck, right? And you have to go manually to the database and unsubscribe them, right? That's an example of this event subscriber. In that case, it's a little different, but the idea is basically the same. So what you just learned here is applied there. Does that make sense? Okay. In fact, also when you unsubscribe, see, when you subscribe, see, I like the YouTube example because you subscribe, meaning, hey, let me know when something happens, and you unsubscribe, I don't care anymore. Same thing here. Plus equals, let me know when something happens. Minus equals, I don't care anymore.
They have actually a bell now. The subscribing, they have like notifications separate for each one. I don't know why they do that, but.
I think because if you subscribe to like 100 channels, you'll get 100 emails saying, hey, blah, so-and-so upload a video. Hey, so, you know, and you're like, dude, my email's getting flooded with all these things. So I think they just do that. So like you can subscribe, but then you can say, okay, I only want to know when Angry Joe uploads a video, right?
That makes sense.
Not PewDiePie, because he uploads like 10 a day or something like that. It's like too much. I'm going to check his channel anyway, so I just won't do that, right? But some people don't like that, because then like nobody gets notified. But then it's like, well, if you're subscribed, aren't you supposed to check your subscription feed and see if?
Yeah, that's what I do. I don't have notifications.
Yeah, exactly. I don't have notifications either, because I go on the subscription feed and I look, there's a new video, I'm gonna watch it.
Apparently, sometimes like it won't even show up on the subscription feed, but it never happened to me. So
That's never happened to me. I use the app, and yeah.
YouTube is strange.
Yeah. Yeah. Maybe they didn't unsubscribe or subscribe. I don't know.
Algorithm is kind of weird.
Yeah.
The worst.
So does that all make sense to everybody? All right, so let's see that in action. Let's do a build. Let me wake up my phone over here. Let's open up our, did I close it? Damn. Okay, open up this. Downloads. I'm gonna do this properly, but whatever for now. Oh, okay. That might actually not work. Hold on.
So you're doing some Windows because of Android development, right?
No, I'm doing it because OBS runs a lot faster on Windows than it does on Mac.
Oh.
Or else I'd be doing this on a Mac.
Yeah.
I think since we're kind of running out of time, next time I'm going to do on my Mac, so we can deploy to iOS. So you guys can like deploy your app from from Unity over to iOS. It's a two-step process. You build to an Xcode project, then you open up the Xcode project in Xcode, log into your Apple account, set up the provisioning profiles, and then build to your phone. So in our case, from Unity straight to Android. Why? Because it's open source. And Google works with Unity, you know, they're partners, so they try and make this as painless as possible. Apple has certain restrictions, which, you know,
Apple lawyer restrictions.
yeah.
Yeah.
So here we go. Bam. Now let me go over here. And let's take a look at our beautiful UI. There's our score now. We see our scores on the phone. Beautiful, right? Ship it. This is whack-a-mole, right? Not bad, right? Cool. Okay. All right. Let's do some audio, right? Because it's kind of fun with the audio stuff, because, you know, it makes things more fun. Because right now it's kind of bland. So, where's a good place when you're doing some, what is this, ticks? Myths about bed bugs? Oh, okay. Oh, this is cool. Actually, I made sort of kind of a game like this, which is actually pretty cool. Yeah, so maybe we can do something like this at some point. It takes a lot. It takes some calculus. But yeah, everything is on a spherical coordinates, right? So when you shoot, you know how you have in a game you shoot and you shoot straight. Here, using spherical coordinates, you have to like have a system. Yeah, so it bends based off the position on this quote unquote planet. So when you shoot, it's really cool because as you're shooting, it can wrap around because the planet's so small. It'll just wrap around. This is pretty cool. I think it's pretty cool. But anyways, so where I like to go to get some free, sound effects just to play around with, for prototyping, is freesounds.org. Freesound.org. Yeah. So I always forget my name, my login. I think. No. Hey, cool. I'm in. All right. So we have a mole. So maybe do like a cartoon pop up. I don't know. Just put something in here. These are too long, so we'll do something like I don't know. Chipmunk. Hey. So, no, don't use that. No.
Here it comes.
Hey, that's pretty cute. I like that. Cause it's I like it. Yeah. Again, prototyping, right? This is just prototyping. So we're gonna save the file. Yeah, exactly, yeah. Yeah. We can change it where like the longer the game goes, the pitch goes down. So it's like here it comes, here it comes. You could, I mean, sky's the limit here. All right, so where's our downloads here? Here we go. And just throw it in here. But we're gonna make this nice and organized. We're gonna call this audio. Throw it in there. Cool. And we'll rename this to mole. Well, let's make it a little more specific. Mole pop up. Okay, here's our mole. Now, how do you add audio? You can just drag the audio clip onto the game object here, and then bam. There it is. Now, we need to know when the mole pops up, right? We had already done something like this before. What did we use? Animation events. Good job. Right? Animation events. So let's go to the animation. Remember, there's our mole, right? As we come up, that's when the mole pops up, right? So let's do an event here. We add the animation event here by clicking here, right there. Now let's find it. Well, yeah, we'll need to make a new thing on the mole. So let's go to this mole. Okay. So remember we had this on animation hide, on animation show. Yeah. So let's go back here, click on this. On animation show. Now our mole here, let's go up here. Now every audio that you want to ever play is on a component called audio source, and you feed it an audio clip. The audio clip is this, right? If you click on this, it pops up. You can hit play so you can hear it.
Here it comes.
Right? That might be a bit loud. There you go. All right. So we'll call this I don't know, sound. I don't know. I'm really bad at this right now. So on animation show, we'll say this dot sound dot play. Oops. Dang. Just like that. Okay. Now let's click back on our mole here. Okay. I'm just going to drag this into here. That's it. Hit play. See what happens.
Here it comes. Here it comes. Here it comes.
Right?
Here it
That's not
comes.
gonna get
Here
annoying.
it comes. Here it comes. Here it.
Right? So you can see how we can add audio. Obviously, find something better than that. But something else you could do is if we had if you had an audio engineer that can make a bunch of these clips, you can actually have an array of clips and then randomly pick one. So it's not always the same thing. And then you just say, hey, play this one. So how could we do that? So suppose, tonight or whatever, you're like, oh, this is really cute. I found some audio clips. Well, let's do that. So you can say audio clip like that. We can say show. I don't know what to call this. Show audio clips, something like that. Make that an array. We still need a reference to the audio source, so that doesn't change. But now instead of just hitting play, we can say audio clip equals this dot, show audio clips random dot range 0 to however many we have. Right? We did this before when we did the game manager and we had to randomize the whole. Same process again, a little bit of randomization. Now we have the clip. That's it. Just assign it. And then hit play. Again, kind of hard for you to see because we only have one clip. So let's find another one. Hopefully it's that cute. So here's our array, right, of our audio clips. Right now we have none. So let's get this audio clip right here. Let's just disassign it. So there's no preference or anything like that. We're just going to assign this audio clip right there. There it is. Now let's find another one. It says Disney here. I don't know why. Tickle Chipmunk. Oh, okay, right. Yeah, okay. Something that's really, really short. Oh, I like that. That's really cute. Definitely taking that one. All right, download that one. Oh, what format was that? .wave? Okay, good. As long as it's .wave. So the supported audio formats, I recommend WAVE for small clips. For example, bullet sounds, stuff like that, ricochets, anything that's very, very short, use WAVE so it sounds really, really nice. Use a compressed format when working with background music. Something that's really long, like 1 minute, 2, 3, or something longer, like audio, like from voice, like you have voice lines, for example. Use something that's compressed, like example MP3 or any of those. And then to figure out which ones are supported, you can go on to Unity. Unity supports a variety of them, but then also depends what platform you're on. Android supports certain ones. Apple, for iOS, supports certain ones. Xbox supports certain ones, etc., etc. So you need to find the one that they all support, and it's pretty much an agreement that they all support MP3 and WAVE. But if you want to do something crazy like FLAC file or something like that, then you need to check. So that's just my warning there. So I really like this uh-oh. Okay, put right there. Okay. Mole, pop up 2, which means this one's pop up 1, just like that. I'll just sign this one right there. Okay. That's going to pick a random one, right? So.
Here it comes. Here it comes.
So it's just.
Here it comes. Here it comes. Here it comes.
So sometimes it's, you know. So it's cute, you know, but also kind of annoying. So be careful. Be very careful what kind of audio clips you pick, you know. Yeah. So yeah, be careful. All right. And if it's too loud, you can always just change the volume here, you know. We can even play around with the pitch. So let's bring the pitch down to like 0.1 or something like that. Let's see what happens when we play. It should sound a little deeper. It's like slower. See what I mean? So it's really slowed down, obviously, right? So I think the normal one is at 1. So if we go a little bit higher, it'll get high pitch because it's going much faster. So we do like 2, for example, right? So that was Here We Go, really fast. Oh no, that was Here We Go. Do you see how it sounds more sped up? So what could you do to add another level of randomization to your audio clips to make it sound, you know, a little bit different? You can actually play around with the pitch. So leave it at 1, maybe go higher about 0.1, go lower about 0.05, so it's not too slow. So you have that little bit of variation. In fact, I will link, actually let's look for it now. So it goes on YouTube or whatever. Amazing talk, absolutely amazing talk. Again, by Dice. Okay, I'm not a fanboy. What is this? Oh, okay. I just really like the way Dice makes their audio. Has anybody played Battlefront, the Star Wars game?
The old one?
No, the one by Dice, by EA. It is. Oh my god. Probably the best sounding and looking game like ever.
Yeah.
So they did a Dice what was it, a GDC Dice GDC audio or sound. It's one of these ones. Aha, here, this one, absolutely amazing. Their workflow is just mind-blowing. In fact, how I told you about randomizing the pitch, it's basically what they do. But that's like grossly, like, you know, simplifying it. They mess with the pitch, but they do a bunch of other things like filtering and adding reverb and different effects. And it's just, you know, let's just look at this. It's amazing. Audio on the speakers here because they don't.
All right, I think we can start. 3:30. Let's settle down.
I think it's. They even show you like their flow, like how.
Right, we had some technical problems. Hopefully everything works now.
Amazing.
Thank you, computer.
Right here.
I'm David Yugutidze, sound designer at Dice.
Here, hopefully.
It's a sound that previously appeared for something else, and reusing sounds like that is never a problem in the movies because there's often a lot of time that passes in between those moments, and what matters more there is what works for that scene. But in the game, you can have all weapons potentially next to each other, and it wouldn't be good for player information to have some of them share the same assets. And also, when you unlock a new weapon, you don't really want it to sound like what you just had before. So, how did we approach making most sounds in the game? First off, we would define what the sound is. We would look at the reference. We would see how clear is the reference and does it overlap with anything. Often, if there's a reference, then we would remaster the assets. Here's a spectrogram example of a Tatooine wind. So you read it bottom to top, low frequencies to high frequencies, and as you can hopefully see on the right side, there's more content in the higher frequency ranges, which is what you lose mostly through older recordings on tape. And we do that through a variety of tools where we bring out some of the weaker or filtered frequencies, and we would also add content on top that fits to the source underneath. When we make something new, of course, we have to make sure that it seamlessly fits into the soundscape. Ideally, someone new to Star Wars, maybe someone like that exists on the web, on the map, always unique in the sense that...
Look at their filtering for their effects. That is insane. When I saw this, I was like, what? No, not sound. This is one sound getting filtered to this for this specific sound clip, right? Now, a lot of this is probably shared because they're using like this node-based way, but where he has circled here is probably the stuff that's getting shared, and this is probably the stuff that's going to make it unique. For example, if you played a Battlefront, when you're outside of a cave, it sounds different, and then as you start walking in, you can hear it echoing, and you have that sense. And then like when you're in space, like inside of the cockpit, inside one of the X-Wings, it sounds like you're inside versus when you're outside. And that's all being done through this filtering process. In fact, they show you some examples.
It is in the same environment, just based on the environment. Right, and here...
Just, you see what I mean? So could you accomplish that in Unity? Of course, but you know, it's gonna take you some time. These guys have been doing this for a long time, right? Could you do it? Heck yeah. But you know, check this out, this is cool.
Here's a comparison of what the 11 sounds on different distances. And that's different filtering and different content for each of those distances. There's some further stuff going on. So we help out our obstruction system in a combination to where the sound is.
The stormtrooper in the cave system.
The reflection content in the throw environment. T97C sounds like a microphone, and that's it shows you how the content changes again for the different environments and how the obstruction works when someone moves from outside to inside, or
Right? So you can hear these subtle differences, right? So when you're picking your audio clips, you want to make sure that you're not always playing the same effect. You can still play the same effect, but you might want to add some filtering, right? And Unity has a lot of filters that you can actually have already out of the box, including like reverb. You can also do low pass filters, high pass filters, stuff like that. To do the distances, stuff like that, you can get some help from the audio source here. And on this 3D sound setting, you have this curve, right? So you can start pulling, you can start playing around with this, like spatial blend, spread, reverb sound. You can start pulling these things around and start playing around with them. So you can, remember Unity is this whole drag and drop stuff, so it's very interactive. So you can start pulling the graph and start building your own things. So as you can see this graph, for those of you that are doing like, was it 196V? Look, you can do a graph right here if you needed to, right in Unity if you wanted to. Right? There's a lot of things you could do with this. So it's pretty nice. Just saying. You know, you can add nodes, you can remove nodes, stuff like that. So just by double clicking here, we added a new one for this one. We can bend it, stuff like that. We can do a bunch of stuff, whatever it is that we need to get our perfect graphs for our sound. And usually programmers don't touch this. You usually hand this off to a sound engineer. They went to school for this, they study this, you give it to them, they make it all beautiful, and then they give it back to you, and you just plug it into your game, and then just right? So I'll link that. In fact, I'll just do it right now. So for those that aren't here, they're just gonna look at the like, what the heck is this video, you know? But you know, I think it matters, especially audio, and then especially because it's coming from Dice, and I think Dice just does a fantastic job. So here we go, and where are we at here? I'll just paste it right there. I'll just do it here. Just put it right there. There we go. Very cool stuff. Again, this is a game-oriented club right now. So, yeah. So, oh, and the modular stuff for like their vehicles. Again, watch this. I watched this. I thought this was absolutely amazing. In fact, I'm actually building a new computer specifically because I want to show you something. Because I think this is very, very cool. I'm not a modeler. You know, I don't know how to like, you know, make 3D models. But I have a camera. So why can't I just go out into the real world, find nice foliage like rocks, maybe some trees? Why can't I just take a picture of them and just bring them into my game? Right? So, a talk on bringing the art of Star Wars in photogrammetry. Why does it look so beautiful? Because they did this. Right? And here's a really good talk on that.
Hi.
Not this guy. So let's just move that. Skip track.
Hello. All right. I think we'll start. We got a lot to go over.
That wasn't photogrammetry, such as marvelous designer to create cloth, supplementing that with things with hard surface modeling, just the usual way we do it, and combining all those pieces into kind of a final result with many techniques. Here's some quick final renders of the in-game assets themselves. And
I found this to be incredibly interesting, and I feel like this is going to be the future of gaming. Right, this was done 3 years ago. This particular talk, Battlefront 1 came about 3 years ago. Now this is incredibly important. Okay, it's all about iteration, and in a lot of these companies they use like this agile process and stuff like that. And check this out. In Battlefield 4, right, that was the game that had come out just before this game. That game looked impressive, very impressive. It took them about 2 weeks, 14 days, right, to start building out some certain assets. It took on average some of these big assets about 14 days. Using photogrammetry, it took about 6.5 days, let's say 7 days. And the fidelity between the two is incomparable. You have somebody that's modeling something versus somebody that's out there just taking pictures of something, right? Could you do that? Yeah, if they got a contract with like, you know, the US Army or something like that, and they go take pictures of their tanks, just put it in, just like, the tank looks like it's real. Because it is real, that texture is real. All the details are coming from real life. Yep, and that's why I'm building the rig specifically, because I want to show you guys how to be able to do that. So we'll have like a lab where we're going to take a picture of each other's faces, and we're going to create a 3D model of our face and just And we'll throw it up in Unity just so we can see it, right? The thing is, it requires a really beefy computer. But yeah, photogrammetry is like, it's gonna be the future. Cause me as a programmer, you know, I'm not really good with like 3D modeling, but like, you know, what if I just needed a rock? I'm looking for a really good rock, and I go outside, I'm like, man, this rock would look so cool in my game. Start taking a picture, and then just throw it into like, it's called Mesh Room, throw it in there, create the 3D geometry that I need, and just clean it up, and then bake. You know, there's a talk called Bake It Till You Make It. Basically taking high poly meshes and then baking it down to something small and using the normals, right, to actually extract all that high fidelity information. So you have something that's really low poly but looks like it's high poly, right? That's good. That's because it needs to be game ready. See, look at this. The blue part here is high poly. They created something that looks fantastic, all the details. The problem is that you'll have like a rock that'll be like a million vertices. That's just one rock. There's no way you could have multiple of those in a game, right? Impossible. So what do? You need to figure out a way to, they call it retopology, right? This is now looking at the mesh as just the vertices. You need to make it, you need to, you know, rework it in such a way where you can still keep a lot of those high details, but with less and less faces, making it faster and faster for it to work on your game, to make it more optimized. That's what this retopology part is for. And then you have the UV layouts. And again, this is more on the modeling side, but the UV layout uses UV coordinates. Think of UV coordinates as X, Y. So you have a 2D image that will be projected onto a 3D object. So the UV coordinates needs to be done in such a way where when we put this 2D image onto our 3D object and it wraps around, that we don't get any artifacts, or we minimize the amount of artifacting, okay? And also, if you've ever seen somebody do a UV layout, you know if they're a good modeler if their UV layout makes perfect squares, or as close to perfect squares as possible. That's because you want to make sure that all the warping has been taken into account, because you have a sphere, that's not a square, it's not a cube, right? But if you do the topology correctly, then you should have perfect squares around your sphere regardless. It just means that all the warping has basically been done, has quote unquote been kind of undone in a way. So it's perfect basically. It's a perfect wrapping. Then you have the texturing part. Now they have the UV layouts. Let's start to texture it top. And then setting it up. I think this process will probably be taking it from like Maya, 3ds Max, whatever they're using, Blender, and then bring it into their engine. They're using Frostbite engine, which is basically it's Unreal with a lot of mods from EA because they bought it. So they have their own engine called Frostbite that comes from Unreal. So they're going to bring it into Unreal, or Frostbite engine, call it Frostbite. That's what it's called, right? Frostbite. They're going to bring it in, set it up, and get it linked into their game, and then bam, now you have Yoda, now you have Leia or whatever in your game, right? And in the case here, this is Star Wars, right? So, and now the turnaround time is a lot faster, right? So here's an example. I forgot what that program was called. It was called, oh no, this is from Photoshop. Because they're trying to remove the lighting. Aha, here it goes. This is what you want. This is, I forgot what this program is called. Yeah, go, Agisoft Photoscan. That's not free. In fact, it's quite expensive. Meshroom is open source. So that's good. Those blue things that you see right there are photos. So you're going to take photos with your camera, and then the program, in this case Agisoft, Meshroom does the same thing, can actually figure out where you took that picture. And then it does this projection. And then you have this. This is a rock. Except it's big. It's too big. So you can see you have this high poly, right? Rock here.
We would take it into TopOgun or any retopology software of your choice and retopology.
And bam, now you have these perfect checkerboards, right? They've already gone through this retopology part, and they fixed the UVs. Now you have these perfect squares. If you don't have this, you end up with like a bunch of like warping, right? That's kind of what you don't want. Okay. So this is them creating their UV layouts.
Guys,
So it's all pretty now.
we would
And now this is another thing. So you have different layers for the texturing. Texturing is not just the colors. It also has to do with the height maps, the normal maps, and then your actual texture. So these 3 different textures that will be laid onto your whatever model you're using. So the height maps give depth, things that extrude out. Normals are supposed to be for like same thing, but very minor details. Things that like for example, you can have a texture of rocks that's flat, but then you built a normal map onto it, and it'll almost look like those rocks look like geometry, but it's not. It gives you the illusion that it's geometry, but it's not.
So color, make a little bit. Once you remove the shadow, then you can move 5 texture pixels per screen pixel.
So again, this is working more. Again, this is using probably Maya, I think, or something like that. So you can see how they have the little stormtrooper, and they're just trying to figure out how does this rock look like with my stormtrooper, or whatever. So good stuff. But anyways, back to our whack-a-mole game. So yeah, does anybody have any questions on any of this? So we got the audio done, so that's cool. And it works on the phone, so that's cool. So yeah, does anybody have any questions? Anybody having any issues or anything like that? No? Okay. I'm gonna post this onto GitHub, so then if you're following along or whatever, you can grab this. You should be working on your own project, so you should have your own project, and then you can pull from this and then just compare. So hopefully you guys are on the same track. So make sure you don't download you don't clone and then open up that as your project and start modifying, because I'm going to be pushing things and it's going to break. So you have 2 projects, work on your own project, and then use this as a comparison, so you can look at the code and see what's going on. All right. Anybody have questions? No questions? Questions, comments, concerns? Nothing? Okay, cool. All right. Well, then we'll call it a day, and have a good weekend. I'll see you guys on Tuesday.